Assalamualaikum warahmatullahi wabarakatuh and good morning. So my subject, which is BMM3562, finite element method, giving a task about linear static analysis of a pull bar. So firstly, I will introduce to you my member group. Firstly is Asyraf bin Jamrus, MH18023. Next is Muhammad Faisal bin HASHIM, MH18003. Next is me, Ahmad bin Muhammad AZMI, MA18121. Lastly is MAGILAN anak lelaki MUNIANDY, MH18021. So, my part is introduction. So, firstly, pull bar is a bar designed for upper body strengthening exercise. The pull bar is also normally mounted between two walls and come with a rubber gripper or other form of gripper to guarantee that it grabs the walls well. It table pull-up bar width is 46 to 50 inch. The ideal diameter for a pull bar is about 1 to 2 inch. And the best part to use for a pull-up bar is metal. There are hundreds of various sizes. That optimal size for a pull-up bar is about 48 inch times 1.25 inch. That is the objective. So the project goal entails the following. Number one, determine the part assembly solid monofacial stress. Second, determine the validity of the part assembly displacement. Third, choose a form principle, a component assembly stress. Fourth, determine the part assembly solid principal stress. Fifth, determine the level of safety in the model you construct. And lastly, six, in the model generate, discuss the result of the solid molecular stress, displacement magnitude, principal is stress, principal is stress, and the safety factor. So that's all for me. I will pass that to the next presenter. Thank you.
Assalamualaikum and very good evening to our lecturer. So I want to continue the presentation from introduction, and thank you for my friend for present the introduction. Now I will intro the methodology for this our team project. So for this project, we are taken after the really straight work, so that will be after meet the venturer. Firstly, our group do some the discussion for the project. We do some the brainstorm. Some idea. First we want to do is the ceiling fan. Second, study table. Third, book cabinet, and so on. Finally, our group come with the conclusion to choose. So we choose to design a pull bar because it much simpler other much simpler than the other and less complicated to design. So after our group do the decide to the object, we design and we start to design a pull bar. For that, we had discover some the reference from the web magazine and so on. So after we do the some discussion and design, we do the design into the AutoCAD for the edge and the finalize our design with planning to the this step. Fine. After that point, we continue to the examination the portion. In this portion, we have to set a few of settlement boundary, and for the material we use the stainless steel. This is because the stainless steel is more durable and easy to sanitize, and it's corrosion resistant. we also fit to use linear statistic analysis. Uh, finally, uh, finally, we proceed to the improvement at the pull bar, such as we create a new design for a pull bar. This is because to make the pull bar become more stronger and safety to use. At the end of the discussion, we finally come up with the solution for the pull bar and the design improvement. So next, my friend will explain a little bit about the other.
Salam sejahtera. I'm going to present about the design and improvement that we made up on our project, which is pull-up bar. Okay, as you can see in this image, this is the pull-up bar before the improvement. This is so simple, and in naked eye you can see that it is not too stiffy and too strong to handle a large amount of force. Okay, now you can see the next slide is about the after the improvement that we make. So the improvement that we made is just adding a part between the pull-up bar and the wall, so it makes the bar is more solid, more strength, and it will be last longer.
Assalamualaikum, hi, my name is FAISAL HASHIM, and today I would like to present my part on the project, which is methodology. So let's move on to the next slide. For the first slide, I would like to talk about our part and the material used to build up our part. So our part is a pull bar, and the material used to build up our part is stainless steel. So before we start the Nastran analysis, first of all we need to set up a constraint. So before we set up the constraint, we need to choose the phase that we will use to set up the constraint. So in our project, we will set at the phase 3 and the phase 1, and the constraint will be fixed on that phase. So this is the picture where the constraint will place out in our product. After finish with the setup of the constraint, we will set up the load for our project. So in our project, we will set up the load on the phase 1, which is on the cylindrical rod, and the force value for the load is negative 2000 on the y-axis. So this is where the cylindrical rod and also in the load that we place up on the setup. So lastly, we will set up the mesh. This is our last step before we can go to the Nastran analysis. So the mesh setting, the element size is 1.47644 inch, and the mean triangle angle is 20, max triangle angle is 30. So after we finish all the setup, we will be ready to run the Nastran analysis. So this is the picture of the mesh that we set up.
So I will conclude this project. So thank you, my friend. So that's all. I want to thank you, my friend. next, for the conclusion for this project, I will conclude it. So as the conclusion, as appeared within the result and discussion portion in the evidence that we have to make the assessment. Second, this improvement can be seen within the add up and operating and push the examination table. Then finite element analysis is utilized as a framework to calculate and relate a few conditions and behavior of the fabric that cannot be done or inconceivable to attain the tentatively. Last but not least, the design that our group do for improvement proba has been proven by increase the result of straight and strain that our friend explained before this. So I think that's all from our group presentation. Thank you for your time for hearing our presentation. So that's all. Thank you.